Hello, and welcome to the Amazon Web Services Partner Webinar Series. Our topic today features how to capitalize on big data and data warehousing with Amazon Redshift. I'm your host, Sherry Sullivan. I'm here with the partner marketing team in Seattle, and I'd like to welcome you to today's webcast. A couple housekeeping items before we begin. I'd like to remind folks that we are recording today's session, and while your lines have been muted, we invite you to submit questions anytime during this webcast by simply using the Q&A widget in your browser. I'd also like to let folks know that we do make our content available on the AWS SlideShare channel as well as YouTube, and you'll find our recordings to webinars there. I'd like to let folks know that we will take time at the end for questions, so we do encourage you to submit questions anytime during the webcast. I'm pleased to be joined today by Resize, who is one of our AWS consulting partners, and we'll begin with an overview of AWS and Amazon Redshift, and then we'll hear from our partners at Resize on big data challenges and opportunities, as well as customer use case, and how to maximize your business impact with big data and Amazon Redshift. So without further delay, I'd like to please welcome our guest today, Amar Abbas, who's the Vice President of Global Services at Resize, as well as Sankar Narayanan, who is the Cloud Solution Architect at Resize. And we have Matt Yanchin, who is our Ecosystem Solution Architect here at Amazon Web Services. So with that, take it away, Matt.
Thanks, Sherry. So before we get started and actually talk about Redshift, I just wanted to speak briefly about the Amazon Web Services platform. Amazon Web Services is a scalable, secure, and cost-effective platform for running your cloud computing workloads. This is a simple view of the set of services that we offer. The compute, storage, and data services are at the heart of the offering. We then surround these services with a range of supporting components like management tools, networking services, and application augmentation services. All of this is hosted within our global data center footprint that allows you to consume services without having to build out facilities or equipment. There's a lot of equipment powering these cloud services. In fact, every day AWS adds enough server capacity to power Amazon.com in 2003 when it was a $5 billion enterprise. Database services is a foundation service of AWS. Database service customers are offered a broad choice for their database platform, enabling them to deploy the best data store for their use case. All database services are fully managed, which means they provide automated management of low-level administrative functions. This enables developers and administrators to focus on application functionality and performance rather than on patching and backup maintenance. Elasticache provides a managed Memcached service for accelerating frequently read data by caching it in memory. RDS is the relational database service. RDS provides a choice of database engines, MySQL, Oracle, and SQL Server, in a high-performance, durable configuration that can be provisioned in minutes. Multi-AZ replication is a feature of this service. Designed for production instances, Multi-AZ provides one-click DR to a remote data center for fast failover and maximum data protection. DynamoDB is the default choice for new application development. DynamoDB is a NoSQL data store designed for fast, predictable performance at any scale. A feature of DynamoDB is the ability to dial up and down provision throughput in order to meet changes in the workload. Finally, we get to Redshift. Redshift is where we will be spending this session. It's a data warehouse that has been specifically enhanced for the cloud and was developed after many customers requested a fully managed, high-scale option for analytical workloads. So Redshift was conceived with a simple set of objectives: to be faster, cheaper, and easier to use than any other data warehouse alternative. To achieve these goals, every aspect of the service has been optimized for data warehouse workloads with extensive use of automation, I/O efficiency, I/O efficiency is especially important for performance, and eliminating unnecessary I/O has been one of the great focuses of the Redshift team. Here's some common customer use cases that we've seen so far. Redshift is a relatively young service, having launched in early 2013, but already we're seeing widespread adoption in a variety of use cases. First and foremost, customers are able to reduce their costs by extending the data warehouse rather than adding hardware to their additional warehouse. They're migrating away from their data warehouse systems, in some cases completely, and they're able to really respond faster. It all comes down to agility, cost, and ability to grow your capacity with little or no risk. You can scale data warehouse capacity as demand grows, or scale it back as you don't need it. You can reduce hardware and software cost dramatically by an order of magnitude, and we'll talk about this more in a bit. Importantly, your performance can be improved by an order of magnitude as well by migrating to Redshift, and you can make more data available for analysis. Here's an example of some customers who are already publicly using Redshift. Airbnb has been quite vocal about both our Hadoop, managed Hadoop platform, EMR, and also Redshift. Airbnb has seen a 5 to 20 reduction in query times and a 4 times cost reduction over Hive on Hadoop that they were using previously. Accordant Media has seen similar reductions, in fact even greater reductions in query times. And an enterprise customer, Nokia, has seen a 50% reduction in costs and also a notable improvement in query times. So again, you're seeing both cost reductions and actual improved performance when you switch to Redshift. So what is Redshift under the hood? There's several ways in which we reduce I/O in Redshift. First of all, disk storage is directly attached to the Redshift servers, and large block sizes of 1 megabyte are used. Also, we use zone maps to skip entire blocks if the data requested is not contained in that block. A significant factor in Redshift high performance is the use of columnar storage. It's a columnar database, which is optimized for scan operations. So columnar storage is really different from row storage, which is what traditional relational databases use. Instead of locating data in rows in the same location on a disk, Redshift keeps column data physically adjacent. So when performing an aggregation on hundreds of million rows in a single query, such as calculating the average age of everyone in a database, for example, Redshift is able to return the results really, really quickly. One of the features that a lot of the customers that I work with are really excited about with Redshift is point-and-click resize. Any of us who've worked with data warehouses will know that the resize experience can be, well, sometimes a several-week or several-month procurement process once you get that hardware to resize your data warehouse. With Redshift, the resize experience is really easy and really fast. Planning and preparation, as I said, often takes weeks when it's time to execute, but with Redshift, you can scale up and scale down in a single click. By selecting the Resize button on the management console, AWS management console, the user is prompted to enter the new desired cluster details, basically the instance type and the number of nodes you required. And that's it. Your cluster goes into read-only mode while the cluster resizes. And importantly, the cluster stays online. So you can resize a petabyte-sized data warehouse while remaining online in read-only mode entirely. The way this works is that a new target is provisioned in the background, and you're only charged for the source cluster while this is all happening. Fully automated, so data is automatically redistributed to the new nodes after you resize. As I mentioned, it goes into read-only mode during resize, and all of the data copying actually happens parallel node to node, so it doesn't have to go through the leader node. Basically what that means is that resize is a lot faster, it's more efficient, and you're not charged for anything that you're not using. Once the resize is complete, we do a quick DNS flip over, and that way your customers have no downtime, and your end applications can have a fully resized cluster to use immediately. Importantly, Amazon Redshift has security built in. You can encrypt your source data in S3 using either server-side encryption or your own encryption keys. When you transmit that data to Redshift in parallel using the copy command, all of that data can be secured using SSL in transit. And most importantly, when your data is at rest in Redshift, we use hardware-accelerated AES 256-bit encryption to encrypt every piece of data in Redshift. So all blocks on disk in Redshift and on Amazon S3 can be encrypted end-to-end from at rest in transit to process. Also, there's no direct access to compute nodes, so you can shield your data from any rogue operators that may happen in a security event. And lastly, it supports Amazon VPC, and recently we also announced support for resource-level controls, so you can control very specifically what IAM users, what sub-users and groups have access to Redshift resources on AWS. A big part of security is also, well, there's data security, there's encryption, but there's also backup and DR. And how do you recover, if your data gets corrupted or something happens and you need to get back to a previous state? What's great about Redshift is we're constantly replicating. The replication within the cluster and S3 is happening all the time. So backups to S3 are continuous, automatic, and incremental. They're designed, and S3 as a service that we're backing up to has 11 nines of durability. So it's continuous and automatic and incremental to a service that has 11 nines of durability. We continuously monitor the cluster. So for example, if you were running a data warehouse yourself and a node or a drive failed, you would have to replace that and potentially take your cluster offline. With Redshift, all of this is transparent. We automatically replace cluster nodes and failed drives transparently in the background, and stream the data back from S3 as the cluster recovers and we add new nodes to replace the failed capacity. So there's one more point to make about the current state of data analysis, and this is, I think, where Redshift is really a game changer. Various analysts have attempted to quantify the gap between data generated by applications and data that makes its way into an analytical environment. The general trend is that the gap is large and growing, in that people simply can't capture and process the volume of data they're generating. So Redshift is specifically designed to eliminate two of the major barriers to broad adoptions of analytics: effort and cost. Operational data often does not find its way to the data warehouse or any kind of analytical environment because the cost of a data warehouse prevents smaller, less proven data sets from getting entry. On top of this, the effort required to bring data into the warehouse is substantial relative to its perceived value. So Redshift has been built and priced to change this. It's allowing customers to close the gap and start analyzing all of their data. Redshift was built with a focus on performance, price, and ease of use. The XL nodes provide 2 terabytes of storage and cost less than $1 an hour to get started. If you need more than a single node, the single node price is simply multiplied by the number of nodes you provision, so there's linear pricing. You only need to remember one price. You can also reserve instances for 1 or 3 years and save over 40% off the on-demand price for a 1-year reservation and over 70% with a 3-year reservation. Reserved instances apply. All of this translates to less than $1,000 per terabyte to keep all your data online for a full year. Redshift as a service integrates with multiple data services, so it does not stand alone. It's, as you saw at the beginning, we have a broad and deep ecosystem of services that we provide as part of the Amazon Web Services platform. It has direct, I mentioned, parallel copy command from S3 and also from DynamoDB. You can also integrate it with other services running on our cloud computing platform, EC2. EMR and Redshift are often complementary. A lot of people are doing, for example, ETL work on a MapReduce cluster and then pushing that data into Redshift via S3. I mentioned S3 a lot. It's a simple storage service with 11 nines of durability, a great place to not only back up your data, but also to stage your data, for example, between an ETL process and a load command into Redshift, or for long-term backups before you possibly migrate that data to Glacier for long-term storage. Lastly, all of our services are designed to work in a hybrid environment as well. If you have some or all of your data or some applications running on a corporate data center, you can use services such as Direct Connect and AWS Storage Gateway to migrate that data or to leverage that data in a cloud environment like AWS and Redshift, accelerated transfers through Storage Gateway to S3, for example, or Direct Connect to provide a bridge between your on-premises applications and your data warehouse hosted in the cloud on AWS. So I hope that was a useful overview of AWS and Redshift. And with that, I'd like to pass it on to our partner, Resize.
Thank you, Matt. Good morning and good afternoon, folks. My name is Amer Abbas. I'm the Vice President for Global Services at Resize. I will sort of walk you through some of the context around big data and data warehousing and what we're seeing in the market and with our discussions with our customers. And then I'll ask my colleague, Shankar, to talk a little bit about sort of the technical impact of Redshift on and how we've sort of architected some of our engagements. So first, just a quick introduction to Resize. We've been around since the mid-90s. Our core focus is working with companies to provide technology solutions and services with the extreme emphasis on optimizing their operations, costs, and expense. So we're constantly looking to see what are some innovative ways that we can help our customers reduce their costs. And that has sort of led us into a strong partnership with Amazon. We're an Amazon consulting partner and have been for several years, primarily because the solution set helps us provide a pretty strong value proposition to customers where we can help them optimize not only their operating expenses for technology, but really help them speed up and accelerate how they can roll out new applications that can impact their business. We are about close to now around 4,000 employees distributed around the world, fairly large footprint in the United States, and then abroad in South America and Brazil, in India, Singapore, Malaysia, Thailand, and then over in Europe, in Switzerland, Hungary, and Prague. Our focus around big data services really helping customers essentially through the life cycle of their data analytics process. So we'll help the customers with initial technology assessment, evaluation, look at sort of appropriate use cases and how we can define proof of concepts, develop sort of an Amazon-based infrastructure, and that could include technologies such as Redshift, Hadoop, and EMR implementation. So look at what are the optimal ways to leverage S3, and then get a little bit more deeper into the actual application that our customers are most interested in sort of looking at for big data optimization, and get a little bit more detail into actually looking at the queries design and optimization, develop sort of the analytics framework as well as sort of the visualization framework as well. We typically build our solutions around the core Amazon platform as well as some hybrid solutions. We are sort of tools agnostic, so we work fairly closely with some of the visualization and analytics provider in the marketplace today. We have invested a fair amount of energy in specifically the public cloud from Amazon. We've developed a cloud enablement platform that we call Zero, which essentially helps us and helps our customers leverage the various Amazon assets quickly. An example of where people are using Zero is when they really want to optimize and orchestrate complete deployment of Redshift and EMR clusters. So our tool sort of comes in and helps accelerate that process. The reason why we've actually sort of spent a fair amount of time and energy in investing in big data and sort of the surrounding technologies is primarily because we think that there's a huge opportunity within our customer base, not only to help them sort of unlock the value of the data that they have, but really sort of take that and impact their bottom line as well. So a couple of sort of contextual points. Obviously, we are seeing data grow at an exponential rate. Some of the sort of the numbers out there that are public. It's Facebook sort of generating almost 40 plus terabytes of data per day. We're seeing some of the academic institutions with massive amounts of data, and then some of the transactional projects out there and transactional businesses such as the New York Stock Exchange, also generating tremendous amount of volume per day. The other sources of data that are sort of embedded within the organization, and sometimes the enterprises are not fully leveraging them, sort of are what we call the dark data, and that could be historical emails, historical unstructured data that if there was a way to mine, the companies could actually leverage that. We're also seeing a lot of data actually being generated from sensors. We've worked with a couple of customers that have and generate tremendous amount of data from utility meters, water meters around the world, and that need sort of almost real-time processing. And we're also seeing a lot of sort of public data sets being published, and that you see a lot of that in sort of the healthcare and the bio industry, where a lot of public healthcares are actually being, or sort of public data sets are being published, some on Amazon, others in other repositories that can be available for utilization by different organizations. There was a study done probably about 18 or so months ago where McKinsey had actually looked at big data across industries, and what they found was that pretty much every sector had tremendous amount of data. 100 terabytes of data was pretty standard across most of the industries, and 1 petabyte was where everybody was trending. So this was probably 18 months old, so these numbers are probably much more realistic or even bigger than what they found. But what was actually more interesting in that study was that something that they sort of defined as the Big Data Value Potential Index, which basically said, hey, if you can unlock the value of the big data and the various data sets that you currently had, you can actually see a dramatic improvement in productivity within your enterprise as well as within some of those large sectors. So in summary, the output of a lot of this research was, everybody has tons of data, and there's a tremendous amount of potential in unlocking the value of that data. Some of the use cases that are out there, and I know Matt touched on a few, but we spend a lot of time with customers that are in the financial sector, and we'll talk a little bit about that towards the end of this presentation, where they are getting lots of data that needs processing very quickly. We are sort of engaged, in sort of traditional e-commerce platforms where website-based analytics really are being mined together with some unstructured data that they may have from either social networks or other sources. So we see a lot of opportunity and activity in that space. In sort of the telecom space, we see a lot of sort of ways that people are using telecom data for fraud detection, and that may or may not be directly with telecom-related activities, but it could be with sectors as well. So, for example, organization using telecom data to detect fraud in sort of the insurance, healthcare side as well. The challenge that sort of historically has always existed is really there's just been a tremendous amount of bottlenecks in processing big data. So whether that is really from a processing capacity where parallelism, really sort of did not kind of cut the bill and solve the problem of getting the data processed. The other one was where if you actually did do a lot of distribution, your failures, the pretty high level of failures that occurred in distributed computing, and you could not actually process those sufficiently. And then again, as you mentioned earlier, the amount of data is sort of not static, so it continually increases, and you don't necessarily sort of sunset older data. You typically are doing analysis across sort of both real-time data and historical data. So scalability historically has become sort of a big issue as well. So again, problems with sort of the traditional model of computing was that you always were historically processor bound, and when you wanted to sort of relieve the restriction of the processor, you went to distributed systems, but then you sort of ran into the problem of, how quickly can I get data over from one location to another, or how do I sort of effectively distribute it, and then how do I keep track of failures that may occur in some of my distributed nodes and have the appropriate feedback loop in place as well. So some of those issues sort of have historically kept us from unlocking the value of data. And then the other one sort of was that in sort of the historical context, if you were doing data warehousing and you wanted sort of analytics run, it typically was a batch-oriented process, and the number of reports you were running were really in hundreds, perhaps some ad hoc reports, and the user base was actually pretty small. Going forward, though, and what you see in the market right now is, people want to be able to continuously load data into your data warehouse and do it extremely fast, and then allow that to the end users very, very quickly. Then at the same time, we want to make sure that there are appropriate business intelligence and analytics applications that are completely integrated to the data warehousing platform so that the customers and the end users can actually leverage that data in real time and in many cases sort of make sort of dynamic business decisions. So the core aspect of it is how do you sort of speed up getting the data into the data warehouse, and then at the same time make sure that you are actually able to process it and then get it packaged and delivered to the customers and to your constituents. The end sort of result being that we really want to slash the decision-making time as well. We've actually been working with sort of various customers, as I mentioned earlier, in sort of walking them through the various sort of challenges with aggregating data and then sort of getting it assembled and analyzed fairly quickly. And one of the very interesting engagements that we had the fortunate ability to participate in was looking at one of the core issues that sort of led to sort of the financial distress that we had a couple of years ago around the mortgage industry. And there's tons of data that's associated with each sort of mortgage that is actually issued to end users, and there's a whole life cycle that's associated with keeping track of that mortgage and also keeping track of it as it gets securitized and packaged and then sold to investors. And one of sort of the reasons around broadly around some of the distress that we had in the mortgage markets was that the visibility was not clear on what constitutes a mortgage-backed security. So we're working with one of our customers to actually do a fairly sort of complex proof of concept where we take in extremely large data sets that are associated with the mortgage industry. We get them sort of inputted into a data warehouse. But what's really interesting about the data warehouse is that it is sort of extremely dynamic. So as somebody's credit rating is changing out out there, we can actually sort of map the effect of that into each individual mortgage-backed security, so you get a real-time view of what's really happening with those assets. So it's a fairly interesting, complex problem. We did get the opportunity to work closely, with our partners, Amazon, as well as our end customer on that. And we actually sort of developed a fairly, a high-level sort of framework and deployment architecture that was based on kind of using pretty much all the different components of Amazon. So you used DynamoDB, S3, obviously Redshift, and then also utilize Jaspersoft integration that exists with Redshift for visualization. So in this case, a tremendous amount of data was actually sucked into the system. It was fully encrypted, put into Redshift, and then very complex analytics were run in it in real time. And then at the same time, as we were sort of getting in newer data and getting in changes to existing data sets, those were all reflected in sort of the end analytics that were being generated. So fairly interesting use case, and we've had the opportunity to actually work with similar ones that are more tied to sort of traditional e-commerce analytics as well. I'd like to actually turn this over now to Shankar, who can talk a little bit about more in technical detail around this particular use case that we implemented. So Shankar, please take over.
Thanks, Amar. Good morning or good afternoon to everyone. So I'm going to touch upon some of the technical aspects of Redshift and how we help our customers succeed in their big data processing with Redshift and the BI tools. As you would have understood now, Redshift helps to design and build very large-scale data warehouses on demand, right from gigabytes to terabytes to petabytes, and it has a high performance. It's faster, cheaper, and easier. And the best thing is that it is fully managed, which doesn't require a lot of resources to set up and provision the hardware and software that is required. And one of the things that Redshift helps is to heavy lift large data scale processing, where you have a higher flexibility. For example, you can choose 2 terabyte single node to up to 1.6 petabyte cluster, and you can resize that depending on the changes to the
All right. Looks like I think we lost Shankar there. So let me sort of continue with the presentation there. So again, as Shankar mentioned, in this particular case, we actually utilized some of the higher end clustering that was available to us and deployed the system on it. So it included some of the HS1 clustering systems as well as the HS1 XL system with fairly large storage assigned to it. The advantage for us here was that as we were getting in lots of different data, it was changing dynamically, so we were actually able to in real time resize the systems as well. In certain cases, we actually had initially we started out with 2 or 3 mortgage servicers data that was coming in, and then we modeled sort of what would happen if we actually had sort of the full complement of the mortgage services providing us data. So whether it was starting off with 2 and then extending it to close to about 7 or 8, and being able to sort of dynamically grow the sort of the footprint actually really was pretty effective in showing sort of the value of Redshift to us. And again, the data set was extremely dynamic. So as you can imagine, if there are probably about 5 or so million mortgages that are issued out in just the United States alone, and typical life cycle of a mortgage is about 7 years before it sort of recycles. So 5 million mortgages times 7 years, about 35 million mortgage data that is actually being modeled and assembled at the same time. So the scalability component of that typically becomes very, very important. And as we sort of proved in this particular implementation, that the ability for us to sort of scale horizontally was pretty useful in being able to address the issue of sort of large-scale, high-volume processing that we encountered. The other sort of important aspect was, it's sort of great to be able to sort of do a lot of this fancy stuff, but can you actually do it fairly cost effectively? And again, this is sort of where the advantage of working in an on-demand environment typically comes in. So originally, a couple of slides ago, Matt had mentioned that you can get about a terabyte sort of worth of data warehousing for about $1,000 a month, which is really sort of a good benchmark to work off of. But what was really sort of interesting was that all the other sort of associated implements and associated machines that we needed, whether it was EC2, whether it was some of the S3 buckets, I mentioned DynamoDB, all of those, because they were sort of fairly dynamic, we used them for the exercise of processing and then shut them down. The overall sort of cost was actually maintained for this particular initiative. Our initial estimates were, if we had actually done something similar using sort of the traditional model, our cost probably would have been about 19 or 20 times higher than they were where we actually utilized the on-demand solutions from Amazon. The other component, again, that came in that was very important was because we could resize the clusters pretty dynamically, we were actually able to kind of do a lot more sort of to-be analysis as well. So there was a fair amount of algorithmic work that was done in the back end and constant tweaking of various sort of algorithms to figure out what was the appropriate risk for a particular mortgage-backed security, and a lot of those algorithms, sort of being fairly complex, required different types of system and computing capacity. So that was actually also handled pretty seamlessly within the Redshift environment as well. So and then we also were able to not only sort of process the data, but actually get it available in sort of simple visual, or the ability for our customers to actually simply visualize these. In this particular case, we actually used the visualization that was available from Jaspersoft that has some integration with Amazon and Redshift. And again, this was really where we could actually show some of the end user constituents that might be sitting at their desk and looking and utilizing the data on their day-to-day job, that they now have the ability to really slice and dice it in many, many different ways and sort of be able to do it without actually having to submit requests for ad hoc reports to their IT department. So actually transferred a fair amount of sort of capacity to actually utilize this data to the actual end user constituents than we had or than they had access to in the past. Finally, I think from an overall summary perspective, we talked a fair amount about CapEx savings. In this particular case, because of sort of the integrated licensing, both from a hardware perspective as well as some of the BI tools licensing that was available, there was really no CapEx investment period. It was entirely OpEx oriented. And then within sort of the OpEx environment, because we could scale up, scale down pretty much on demand, that was actually kept at a minimum. And then finally, from a productivity perspective, we were actually able to sort of not only assess sort of very complex risk models associated with mortgage-backed security, but really were able to pass that along and pass that information along to the end user community within that financial services organization that could then leverage and benefit from that quicker. It did have, and again, it was a little bit early in sort of building out this solution completely, but from what we know and what the early indications are, that it does have, and it is having sort of a direct impact on how sort of the future of mortgage-backed securities could look like, at least in the United States, if not in other parts of the world. So let me sort of close this session and open it up for questions. With this final slide, we'd love to sort of have the ability to chat with you folks one-on-one, so please feel free to reach out to us, and we can sort of walk you through in a lot more detail on what we sort of have learned in this process, and actually sort of give you some more detailed demos as well. We'd also like to welcome you to visit us at the Amazon ReadMed conference. It's coming up in early November. We are booth 728. A lot of the people that are on this presentation will be there as well, and would look forward to speaking to you. And as Sherry had mentioned, this presentation will be available, so if you do have any questions, you can reach out to us directly. So with that, let me pass it on to Sherry.
Thank you, Amar, and thank you, Sankar and Matt, for providing us with insights into how to maximize business impact with big data and Amazon Redshift. Folks, if you've joined us sort of midstream during this webcast, we do invite you to submit questions, and we've had some coming in. So I'd like to open it up and start with the question is, and I will point this to Matt or to Amar, and Sankar, if you're back with us, feel free to chime in as well. The question is the leader node involved in the data replication and failover of the underlying compute nodes?
Sherry, I can take that. This is Matt. So the leader node is for receiving client queries and for executing the query plans, and it's actually the Redshift managed service that takes care of the data replication for your data warehouse cluster and the backups, etc. It's also worth noting that you don't pay for the leader node. It comes as free as part of the service. You only pay for nodes in your cluster that actually store data. So to answer your question, the replication is a service level feature, not directly tied to your leader node.
Great, thanks, Matt. Amar, I'll point this question to you. Does Dices provide DevOps for cloud computing?
Yes. So we work with our customers to provide fully managed services and solutions. So, apart from helping customers leverage AWS, we also provide 24/7 monitoring, management, and support as well.
Okay, great, thank you. Another question that's coming in, and this is a question for Dices, so I'll point this to you, Amar. Can you help with the initial migration as people are migrating to the cloud? Is that something that Dices can provide service for?
Yes. So we can, like I mentioned earlier, we can certainly help our customers, work with them to understand the use cases and then initiate the migration plan and execute that as well for them.
Okay, great. Matt, I'm going to point this question back to you. When you started your presentation, you were showing a diagram of database services, and can you explain sort of how SAP HANA works with that database services for Amazon?
Sure. So the slide I showed with RDS, Redshift, DynamoDB, and some other services showed our managed database offerings. So you're free to run pretty much any database you want on EC2, which is our VM service, our cloud computing service, including SAP HANA. And we actually offer SAP HANA by the hour, the HANA One product for 99 cents an hour. There's also a number of other SAP certified products on the platform. We don't offer a managed SAP HANA offering at this time. So when you run it, you can run it and manage it yourself on the EC2 service.
Perfect. Thanks, Matt. Matt, can you also, I'll point this question back to you, and Amar, feel free to chime in. How does Redshift cost compare to what cost would have been if you've built out more of a traditional on-prem data center? Can you maybe allude to the pricing for Redshift?
Sure. I think Amazon's pricing at $1,000 per terabyte is very, very competitive and quite disruptive. It would be difficult to replicate this in a traditional sense using other data warehouse alternatives. We worked very hard to not sacrifice performance and to have great performance and to have great scalability and a feature set while at the same time keeping the costs very low.
Great. And another question that's coming in, Matt, is around sort of scalability, but can you use Redshift for smaller workloads?
Absolutely. That's why we offer a selection of node types. We have the XL node type and the 8XL. So it depends on your definition of small, of course, but we certainly have customers running smaller clusters and for smaller data sets, and it's still definitely very cost effective for small workloads as well. There is always a cutover point, and that's why we offer a variety of database services. We'll find that some customers may start with RDS, for example, running a Oracle or MySQL or SQL Server database, and may outgrow that and then move to Redshift. But the same could be true in the other direction. You may start with Redshift and then realize because of the nature of your data or the size of your data store that perhaps it makes sense to move to a relational model, and that's where we work with partners like Dices and the AWS Solution Architecture team to help guide customers to make the right decision.
Great, thanks. Another question, and Matt, I'll point this back to you, is that do you have a test area where folks can check out sort of their data and how it converts into Redshift? Maybe this is something, Dices, you can share as well in terms of this might be a POC project, but it might be a test that folks can try.
Well, the great thing about Redshift and the Amazon Web Services platform in general is that it's pay only for what you need and pay as you go. So you're free to build a data warehouse to test in a sandbox style environment. You can lock down that test environment by running it in a VPC so that it's fully secure. And at the same time, you don't have to commit to any long-term pricing or costs. You can run a test for even an hour and see how it goes and do some experimentation. We have a lot of customers also running their clusters in perhaps a production mode and then have a parallel cluster running where they're trying new schemas or new queries so it doesn't affect their production workload. And that type of flexibility is great on Redshift, not only the ability to resize, but to run whole parallel data warehouses where you essentially learn how to structure your data so that it operates best in production once you're ready.
Great. Another question coming in is, given that Redshift expects table structures to be modeled and ETL changes done before being able to copy your source files with new attributes, what are the best practices to work around this limitation and bring down latency?
That's a great question. So Redshift has an ever-increasing set of functionality to actually do some ELT in the data warehouse itself. However, it also is compatible with a number of ETL tools, pretty much anything that can work with JDBC or ODBC or ideally natively with S3, so you can take advantage of the parallel copy. And if you do, for example, load your data and then you realize that you need to do some transformations after the fact, that's no problem. There's some commands such as create table as, where you can essentially create temporary tables with a new schema or new formats and data types that then you can merge or replace with the existing data with no downtime. So again, there's a number of strategies, whether it's a new load from S3 with the newly transformed data or an in-data warehouse transformation. And again, depending on how much data we're talking about and what kind of transformations we're talking about, how much load, for example, it might put on the cluster, or maybe it's more efficient to do it outside of the cluster. That's something that partners like Dices and solutions architects on the AWS team can help with.
Great, thanks. Well, we've got time for just a few more questions here, but do keep your questions coming in. If we don't get to them during this webcast, be assured that we will follow up with you directly. This next question, Amar, I'll point back to you as, does Dices offer a support model for cloud environments?
Yes, so we have sort of various different type of support models. They can be just sort of monthly, sort of ongoing relationship, recurring revenue type relationship that you can have with us, where our teams are fully integrated and managing solutions for you, or it can sort of be more of an on-demand sort of model where you sort of interact with us when you need help, and sort of we provide that on an on-demand basis.
Great. And to that point, Amar, can you also explain to folks how you support teams in multiple locations across the globe?
So currently we do have a follow the sun model. Our teams are located in the U.S., in Asia Pacific, in South America, and in Eastern Europe. And they sort of work either all of them on a 24/7 basis, or we will actually have a true follow the sun model where our teams will work with your counterparts or your teams in Asia Pacific, and then sort of the workload from there will pass on to Europe and then on to Asia, and then sort of this cycle starts all over again. Great.
Matt, I'll point this question back to you. Can you elaborate on EMR and talk a little bit more about that service? Did I lose you, Matt?
Sorry, I was talking on mute. I made the classic mistake. So EMR is our managed MapReduce service, and it supports a number of different types of Hadoop frameworks at this time, such as Apache Hadoop or a couple versions of MapR. So just like Redshift takes away the pain of managing a very large data warehouse cluster, EMR takes away the pain of running, for example, a large Hadoop cluster. You can also do some more forward-thinking things like, or rather future technologies such as Spark Shark. You can run that on EMR as well. Supports Hive and Pig and all the classic tools you'd expect to see in a Hadoop deployment. And it's very complementary to Redshift, and a lot of people use them together because, for example, using MapReduce for large-scale ETL can be very good. And because it integrates directly with S3, just like Redshift does, it makes it a great tool for managing and transforming data at scale. It's also used in a variety of other contexts, of course, such as genomics or advertising and many other services. So I see EMR and Hadoop in general and Redshift as highly complementary on the AWS platform.
Terrific. Well, with that, folks, I'd like to just flip back real quick to a slide of how to connect with the folks at DISYS. And I'd like to take a moment to just thank Amar Abbas and Sankar Nararanjan with DISYS, our consulting partner, along with Matt Yanchin, our ecosystem solution architect, for joining us today. And I'd like to invite folks, please do reach out to our partner at DISYS and learn more about how to incorporate Redshift into your big data projects. And with that, before you jump off, we do appreciate if you'll just take a moment for a very brief survey. We appreciate your feedback very much. And thank you again for joining this Amazon Web Services Partner Webinar Series today. Thank you.